Hi everyone, I'm Sven-Patrik Hallsjö, Swedish, that's where the name comes from, and I'm a postgraduate researcher in particle physics. Whew, we like long words here. I spent 3 months at CERN building, designing, and using a neutrino detector. And I spent my time 300 feet underground not looking at anyone but this, there you go, marvelous device, a neutrino detector. Before we get there, let's take a quick journey through physics. Now, physics is very cool. It's basically trying to understand everything around us. How does nature work? For instance, look at this lovely projector. You might start asking yourself, well, how does it work? What's light? Actually, how do glasses work? Lenses? Why is the sky blue? And these are quite fundamental questions that were answered surprisingly recently ago. And the cool thing is we're trying to understand the universe. And how do you understand something? Well, you try and compare it to things. A good analogy is, why is your mother's cooking so good? You compare it to something else, someone else is cooking, and that's fine. But we can't do that for the universe. So we have to look at the ingredients. We have to look at the smaller parts of everything. And we've moved from molecules to atoms, and now down to small fundamental particles. Okay, so what are particles? Well, they're just packets of energy whizzing around everywhere. Okay, a bit more helpful is think of them as very small tennis balls, just whizzing around everywhere. Okay, there are a lot of them. So let's talk about two we see every day, even in this room. The electron and the photon. Photon first, light. We see them everywhere, coming off the lights here. They go into your eyes, and that's actually how our vision works. That's what we see. Very cool. You can see a single one of them in a dark room. Usually you see about 10 when you think it's dark outside. The electron, well, that's lightning, that's electricity. Goes through all our wires in here, makes our lovely phones work, makes this lovely projector work, and that's about it. So we know what particles are. There are many of them. They all interact differently. I mean, light and electricity is not the same thing. So what do we do with this? How do we see this? Well, our eyes see particles. Why don't we just build big eyes? And, sorry, missed one thing, is that, I'm jumping, is that particles, you might have heard that particles are waves are particles, particles are energy. Don't think too hard about this. This is just like mood swings. We're all the same people, we have different moods, we just interact a bit differently. Going back to what I was saying before, so how do we see these particles? Well, our eyes see particles. Why don't we just build big eyes? That's actually what we do. Simply enough, we try and build mechanical eyes. I grant you, this sounds weird, and I've got a lovely detector in the lower left corner that looks nothing like an eye. But it does the same thing. It takes a particle, makes it into a signal, and then sends this signal, well, not to our brain, but to a computer instead. Okay, that's pretty cool. What do we do with this? Well, if we know how much energy we have, if we know where this energy is, we can start doing physics. Okay, can we do anything? Can we give it more energy? Is there something cool we can do? Yes, we can make particles go faster. We can accelerate them up to the speed of light, more or less, in big particle accelerators. And I've got one in Lego, if this works, if everyone can see it, with a small Lego ball just circling around here. And that is basically what we do. We send small particles, tennis balls, small Lego balls, around a big accelerator many, many times and get them up to the speed of light, humongous energy scales. Awesome. Where do we do this? I'm sorry, skipping everything here. What else is an accelerator? So these big things are lovely. I'll tell you where to find them. But your phone is an accelerator. Even if you remember your parents might have had, your grandparents might have had one of these old TVs, a CRT TV. This was literally firing electrons at you. You were seeing electrons being fired at the screen. This is a particle accelerator. This is the same thing as the thing that's accelerating that Lego ball around. That's pretty darn awesome. And the same thing with your phone. It just accelerates photons. Microwave oven accelerates photons. These lights, everything is basically an accelerator. Sure, different energies and things, so we're not getting microwaved by all this. But where do we get all this? Where do we see these cool things? We go to CERN. CERN is the European Organization for Nuclear Research. If I remembered all that, it's in French. French is complicated. This is, and of course, Geneva, Switzerland. Switzerland's lovely. Think of this as a 5-star hotel, maybe in Dubai, somewhere warm, sunny, all-inclusive, all the booze you can drink, all the food you can eat. Of course, we don't get food or booze, but we have everything we need to do physics, everything we need to build accelerators. We've got huge, big collaborations, people from all over the planet working together to look at really small things. So huge collaborations for small things. This sounds counterintuitive, but we need big things. For instance, one of the detectors we've got there, the Atlas detector. You can probably not see this, but there are some people standing there to show you the scale. This is massive. It would not fit in this room. And we're looking at things that are, incredibly small particles that whiz around every day and we don't see them. And this is what we see inside one. We see energy being deposited here and there. We see particles going through different types. And this is what we use to do physics. Of course, we don't look at each one and try and figure out what happened. We shove it into a computer, and the computer tells us what happened, what was going into it, and things like that. Yeah. So this is all cool. This is not really my research. This is kind of leading up to it. So far, it's been easy, it's been calm, it's cool. Photons, I was saying before, give us light, they interact in our eyes. They do this all the time. You can see a single one. I work with neutrinos. Neutrinos are lovely, and 100 trillion of them go through you every day. They don't interact, so don't worry about it. The probability of this happening is like being struck by lightning while winning the lottery. Okay, so do I just sit around waiting for a couple of years for this to happen? No. Nature has been really kind to us. If you put steel, bedrock, something that's not a human, something that's not water for that matter, this probability goes up a lot. Okay, so our eye idea doesn't work anymore. We have to do something else. Let's go back to my detector. I hope you can see this here. But basically, we've taken an eyeball, one of these old detectors, split it into different parts, and then shoved loads of steel in between. So we see something, or maybe not. We let it interact in the steel. Do we see something after that? Hopefully. And then this goes on for a while. So we can actually see these neutrinos going through our detector in a lovely fashion, just like we were doing with the photons and other particles. And that's it. That's my research. Let's take a step back. Okay, because physics is cool. This is interesting. But how does this affect our everyday lives? What do we give back from this? Well, this is the cool part. Think of the internet. Think of refrigerators. Think of MRI machines. Okay, refrigerators weren't invented at CERN, but they were improved at CERN. Everything else was invented at CERN. These are things that we're not trying to build. We're not trying to improve a refrigerator at CERN. These just come out of us trying to answer these cool fundamental physics questions. And that's kind of impressive. We're just getting this more or less for free while we're trying to look at these small particles, trying to answer the big questions. And then, finally then, what are these big questions? Is there anything left to answer? Oh God, yes. The fundamental question, why are we here? We have no idea. We're working on it. We might have a solution in a few years, is what they always say. What happened at the Big Bang? Okay, 10 seconds after the Big Bang, fine, that's quite well understood, that's physics. At the Big Bang, nobody knows. Hundreds, thousands of people are working on this. And you might have heard of dark matter, dark energy. These are things we're just starting to explore. These are concepts we just have to try and figure out. And the cool thing, and I mean, it's hard to fit this into 10 minutes, but I'm just one person here at the physics department in Glasgow Uni. We've got millions, tons of people working on different fields of physics, doing amazing research, amazingly interesting research from gravitational waves that you might have heard of a while back, to particle physics and everything in between. And we're sitting here trying to answer the fundamental questions of life, the universe, and how everything works in different ways by doing insane experiments. Thank you very much for your time, and have a lovely evening.